An exam question paper is a chess game. When you sit for an exam, you are literally playing chess with the examiner. In question 5, which deals with functions, the examiner has some of the best moves. However, let's all thank God because I will share with you the grandmaster moves. Question 5 reads as follows. The graphs of the functions f of x is equals to ax minus x1 times x minus x2 and h of x is equals to 6 over x plus p plus q are drawn below. What we are given here, we are given a function of a parabola, and we are given here an intercept form. You must remember that a parabola has 3 forms. The standard form, which is given by f of x is equals to ax squared plus bx plus c, and it can also be given by a turning point form, which is given by ax plus p squared plus or minus q. And of course, the third one is the intercept form. You need to know all these 3 forms because you might want to use them when you're solving parabolas, or they could ask you any of these forms. And a parabola, a hyperbola, we all know that it has a form of y is equals to a over x plus or minus p plus or minus q. And the values here of p are actually telling us the left and right movements. And the values of q here, they're telling us the up or down shifts that the graph will absorb or take. The other thing that we might need to observe about these functions is to actually look at them on the sketch. You would see that this parabola here will represent the function f, which is given by this formula. And this sketch here, together with the asymptote, it will then represent the hyperbola. The question continues to say that the horizontal asymptote of h is y is equals to 38 and f intercept the x-axis at a and b. Now, with the first statement is that we are given a horizontal asymptote, which is a line that the graph h will never cut, but it will move as close as possible to it. And they say it's 38. That means the value here of y would be also 38 there. And they further say here that f has the intercept at point A and point B here. These are the x-axis intercepts. This is where this graph will intercept the x-axis. Now, these values are actually the values that we're going to use for x1 and x2. So x1 will be a 2 here and x2 will be a 4 when we use the intercept form, because the intercept form basically gives us the intercepts that we have with the x-axis. Now, we are further told that the points C, D, and E, C, D, and E are the intersections of F and H. Now, this means that this is the points where these 2 graphs cut each other, where they cut each other here. Now, with these points, what they mean that the x values and the y values are the same for both functions. Now, if I were to trace the x value of the function f here, the 6 here, I will get that number. But if I were to trace the x value of the hyperbola here, I will get the same number, 6. That means they share the same number. And the same is true if you look at the output value, the y value here. You will find that the value for the function f will be this number here, and also the value for the function h will be this number here. So they share the same x and y values. And the same will be true really when you look at point D or you look at point E. They'll also have the same x and y values. Now, the last part of the question says T is a turning point of f. So if you look at point T here, it is the turning point of f. That's where our parabola actually turns, and it has a minimum turning point, if I can put it that way. So already we have a hint that the value of a here should be a positive number, because it's a happy graph. We're having a happy graph here. There is something very interesting about this graph, is that if you look at this line here, which is the vertical asymptote of h, of the function h, this line cuts at the turning point of f. In other words, this asymptote here of h, it is the axis of symmetry of our function f. So if we look at the distance from here to here, it is the same as the distance from here to here. So the parabola is symmetrical. This side here is exactly the same as this side. That's a very important thing to observe. It will assist us a lot when we answer our questions. Now, I think I've done plenty of interpretation on this question. We'll move into answering the questions now. Now, when we look at question 5.1, they say to us here, calculate the vertical asymptote of h. So we want to calculate this asymptote here, the vertical asymptote of the function h. Now, I have said that this vertical asymptote, it is actually the axis of symmetry of the function f. So that means now I can then calculate this as if I'm calculating the axis of symmetry of f, and I'll get the same number. So we know that if we have an intercept form, the axis of symmetry is defined by x1 plus x2 all over 2. So what we're basically doing with this formula is that we are saying the distance here, if we cut it in half, if we divide it by 2, we will get equal parts this sides. That's what this formula is saying from the intercept form. It's a formula that comes from having the intercept form. And at this stage, then, it becomes a substitution problem where we're going to put a 2 and we put a 4, we divide by 2. Remember, my intercepts, they are both a 2 and a 4. And this will simplify down to a 3. So that means here we're going to have an x is equals to 3, because I'm dividing a 6 by a 2 there. Now, this means then that the value of x here is actually a 3. We are having a 3 there. Now, this question is worth 2 marks. So that means we are going to get a mark for substituting in the equation and also the final answer. Going to the next question. (5.2) Write down the domain of h. Now, before we can even answer this question, what is the domain? Now, a domain would be defined as a list of x values that give us y values. So the input values that give us the output values. How do I mean? If I were to trace values here on this function of h, so I'm going to focus on the function of h. If I were to take a number here, I input a number here, a negative x number here, this number would give me a corresponding y number. So the x value here gives me a y value there. So it means we have a point that's defined there. And I can take another number, perhaps somewhere here. It will also give me a point somewhere there. I can take another number here. It will give me another point there. So these numbers here of x are actually defined that they give me the corresponding y value. Input gives me the output value. And I can continue doing this infinitely many times, tracing different points on the function. However, you'll notice that when I get to this point here, 3 here, the function is undefined, because remember that the function does not cut the asymptote. So if we put a value here of 3, we don't have a function. The function will move as close as possible to the asymptote, but they'll never touch each other. So it means the function here is undefined. But when we go past that point of 3, maybe we come to this side, the function is actually defined. We start getting points there that are defined on that side. And we can continue doing this as many times as we want. You would realize that this will continue until we go to infinity. So we can take all the x values until we go to infinity, and we can start also here from negative infinity. So this means in a nutshell that all the x values here to this point and from this side to that point, they actually give us corresponding y values. So all those input values give us the output values. And that is what the domain is. So to put this down, actually I'll write it in a form where I will say that x, because we're looking at the x values when we deal with the domain, is an element, is a list of all the real numbers. Remember, the values that are here are real numbers, right? But there's an exception here. The only real number that we're not going to include is a 3 here. So I will say here that I'll put a comment and say x should not be equals to a 3. That's one way in which you can write the domain. Or the other way in which one can write the domain, you can say that if we move from negative infinity, which is not included because we don't know what type of a number it is, we only that it is negatively large, and we move until we get to a 3, because remember the 3 is not included. I'm using a small bracket here because the 3 is not included. And then we're going to write the union. We move from 3 and then we go to positive infinity. So all I'm saying is that if we move from all the negative values until 3, right, which is here, from all the negative values that are large until we get to 3, and then we exclude 3 here because we use small brackets. So union would mean that you combine those numbers. So if we combine those numbers excluding 3 and then we go to positive infinity from 3 to infinity, those are all the values that will define this function, the x values, the domain that will define this function. Now this is only 1 mark, so you should be able to spend a minute, 1 mark for any of these two, any notation. You just have to choose one notation that you can use. Now moving on to question 5.3, we are requested to calculate the value of a. Now if you look at a, it is on the parabola, it is on our function parabola. So to answer this question, really what I'm going to do here, I'm going to take our original function given by the equation f of x is equals to ax minus x1 times x minus x2. And what I'm going to do here is that I will say that my intercepts, we know them, they are a 2 and a 4. Because these are the x values that we have here, a 2 and a 4. Now following this, it means our function is looking like that. Then I will say I'm going to use a point C, which is defined by 6 and 14. Remember, point C lies on our parabola. It is a point on our parabola. So I'm going to use that point. And when we use this point, you can see that this is the x value, this is the y value. Remember that f of x here is the y value, and x would be our x value here. So that means here I'm going to substitute to say my f of x, my y value is a 40, and I'm looking for a, and here I'm going to have a 6 minus a 2, and I'm going to have a 6 minus a 4. At this stage, then this question becomes very, very, very boring, because this is a simple arithmetic to deal with. Obviously, here I'm going to have 6 minus a 2 to give me a 4, and 6 minus a 4 to give me a 2, and here I'm having a 14. So this would mean a would be multiplied by an 8 there. Perhaps I can write this as 8a, and this side I'm still having a 14. Now when we divide both sides by an 8, we should get a 40 divided by 8, which should give us a 5. Remember, I'm dividing by 8 here. The 8 and the 8 cancels to get that. Then a 40 divided by 8, it should be a 5. Now when you look at this number, I have a lot of confidence in it because it makes sense to me. Remember, we said we are having a happy graph. We expect to get the value of a to be positive so that our graph becomes a happy graph. Now, for marking this question, it will be worth 2 marks really. And what they will mark in this question, you will get a mark for using this point, substituting the point on the graph and finding the value of a. Now, there's another way in which this question can be done, and I want to share that way with you because remember, we want to leave any stone unturned. Now, here I'm going to use a symmetry, and to use a symmetry, I will argue to say the distance from here to here is a 3. So the distance from here to here is a 3 because I'm moving from 0 to a 3. And if we also check the distance from here to somewhere here, it should also be 3. If I take an equal distance again, Now, I'm using a 3 here tactically because I realized that the 3 plus the 3, the 3 that we have here plus the 3 here, it will give me a 6 somewhere here. It will give me a value of 6. Remember, this 3 here is just the length here that I've moved. So when I add the 2, it means from here to here, it's a 6. Now, this is very critical because it means now that the 6 is this point here. 6 and a 40, I get a 40 here. Is a point that we get a 40 there. Now, you have to realize something. We started at 0. So that means if I put a 0 on this function, I'll get a 40 as well, right? So by symmetry, we can actually determine this point. So we know that this point will be a 0 and a 40. Now, I'm going to argue that using symmetry, the y-intercept of f is, so it's going to be given as a point of 0 and a 40. You must notice that this point here is a y-intercept. It's where the graph intercepts the y-axis. Now, I'm not going to do this question here because, you can do it on yourself and, I'm giving you an opportunity to practice as well. But the idea is that if you have this point here, you can actually take this point and use the same method we did here. So please try that and see if you get the same answer. Now, the next question will be question 5.4, which says calculate the coordinates of t, the turning point of f. Now, we are requested to find the coordinates of this point t, which is a turning point. Now, to get this, you have to realize that our x value is 3 there. So that means if we put 3 here as the input value, we get the y value here that will be here, right? So, and if I have this y value, then I can write this as a coordinate. So I know that I have a 3 already there. Now, to do this, really, I'm going to use my original equation that we have built up. I'm going to say this is 5.4. I'm going to say our function f is defined by f of x is equals to 5, because already we know that a is a 5. We have x minus 2. We have x minus 4, right? This is how our function is defined. But now I'm going to say that at the turning point, at TP, x is equals to 3, as I said. And this would mean then that I'm going to look at the function value at 3. I'm going to look at the y value at 3, as I was showing here. To say we're going to look at the y value at 3. So this would mean that now I'm going to have a 5. I'm going to have a 3 minus a 2 here, a 3 minus a 4. And if we simplify this, we can quickly see that we have a 5, we have a 1 here, we have a minus 1 there. And this would mean that my function value at 3 is indeed equals to negative 5. So this would mean that my turning point should be given by a 3 and a negative 5. And when you look at this on the graph, it actually makes sense to say this is negative 5 because it's on the negative side of the graph. And also just to look at the turning point form, you can see that this graph actually went down by 5 units. Our Q there is 5, so it went down by 5 units. Now it is possible to also, at the, like when you are here at this point, to take this equation and really expand it. You expand this equation so that it sits in a standard form. And when you do that, you will actually get an equation that looks like this. It will be, let me write this in a different color. So this will be given by 5x squared minus a 30x plus a 40. You can still then substitute here the 3 and you should be able to get a 5. Right, I know that it is, there's other ways of finding the turning point. So one can, use this to say x is equals to b over negative 2a, or one can use calculus where we look for the first derivative and equate it to 0 because the stationary point, find the values of x and then put it to the original equation to then find the corresponding y value. But it is not necessary to use these methods because already we have the x value here. It will be a waste of time. So here you just have to find the function value from the equation that we're given. It's either you can just use this equation here, or you can take it here and you come here and then you find the answer. Now this question was out of 3 marks. So the 3 marks will come from substituting your correct values and finding the point itself because they wanted the coordinate here, and also they give you a mark for simplification. Now the next question, which is question 5.5, they say to us, write down the range of f. Again, before we can attempt to write the range, perhaps the important question would be, what is the range? So the range is exactly the opposite of what a domain is, in a sense that the range would be a list of y values that have corresponding x values. So these are output values that we can map back to the input values. So what I mean is that because we're looking for the ones for f, which is this function here, I'm going to focus on the y values. So we are looking here at the y values. So this means that if I take perhaps a number somewhere here of y, it will give me the corresponding x value here. If I take a number here of y, it will give me the corresponding x value. Continue doing that infinitely many times, you will find that all these y values, they give me corresponding x values. And I can continue doing this even on the negative side, and you'd notice that here I get 2 x values. So this will give me the x value here and also give me the x value there. It will continue doing that. Until such a time where I reach the minimum turning point, I mean to say. If I come below the turning point, there is no function of f. That means the function of f is not defined here. So there's no function of f. Now, if we were to map all these values, you would see that they begin here at 5 and they will go to infinity. Remember, with functions, we draw these arrows here because it means these functions will go until infinity. They don't actually end there. So my y values will start from -5 and go into infinity. Remember, we know this point here to be a -5 the time we're doing the turning points there. So that means my range will actually begin at that -5. The range will begin at -5, which is included. I'm using square brackets because it's included. If you put a 5 here, you get the corresponding y value. It's part of the function. And these numbers will move until we go to infinity. And infinity is not included because we don't know what type of a number it is. We don't know how it looks like. We just know that it's big. So we cannot include a number that we don't know. So this will go until infinity. Now, another way in which one can write this, or another notation that one can use, is to say -5 is less or equal to y. And here I'm using y because we are dealing with the y values, that is the range. But y would be less to infinity, to positive infinity. And all this will guarantee you 1 mark, any notation that you use them. Question 5.6 says to us that we should calculate the coordinates of D and E. Now we are required here to calculate the coordinates of D and E here. Now when you look at D and E, is a point where these two functions are actually equal. Remember we said they have the same y and x value. They have the same y and x value. So this means these two functions are equal at that point. So what I'm going to do here is that I'm going to say that the function f of x, the y value, remember f of x is a y value, is exactly the same as the function h of x, the y value again. So I'm saying the y values of x are this of f, the function f, are the same as the y values of h, because that's where they intersect each other, that's where they cut each other. However, we know that f is defined by, remember I can either use this one or I can use this one because they're both the same. Now I'm going to use this part of the equation simply because this one will require me to come back here when I simplify this. So I'm going to start here to save time. I will say here that my f of x is given by 5x squared minus 30x plus a 40. So just to check there, yes, it looks good. And we know that our h of x is a 6 divided by x. Remember, we know the value of p here. We know that our p here, the graph shifted actually to the right by 3. So that means here we're going to have a -3. Because remember, when it goes to the right, it becomes a negative. And we also say that this graph went up by 38 units because our asymptote is actually at 38 units. Remember, when you move a hyperbola, you actually move the asymptotes and then the whole graph move. So we know that our p here is the same as the q is 38. So this here would be a positive 38 since it went up. You know, remember, moving up, we add instead of subtracting. Now at this stage, we then have to solve for x in this equation. And after solving for x, we then, find the y values. I would tell you that already we'll have 3 points here that we need to get. There will be 3 points. Why? Because we have the point C, we have the point D and E. So it means our values of x, there will be 3 values of x that we'll get from this question. So this means we are going to deal with a cubic polynomial equation. Now let's go and solve this. Well, the first thing that will come to me naturally is that I'll take the 38 to this side so that I have 5x squared minus 30x, and I'm going to have here 40 minus 38, and 40 minus 38 will give me a 2. So that means here I'm going to have a 2, and this side I'm going to be left with a 6 divided by x minus a 3. Now from this point forth, we are going to cross multiply by this 3x, this side, so that we are going to have 3 minus x, and we're going to have here 5x squared minus 30x plus a 20 being equal to a 6. Remember, when we cross multiply, this will come this side and disappear. Or you can say that you multiply here by x minus a 3, and then they cancel out, and what you do on the left you also do on the right, and then that's why we have this here. Now this looks good. Now it's getting much more simpler. We're trying to simplify it to be much more easy to work with. Now at this stage, you'll see that we have 2 products here. We have a binomial and a trinomial. That means I can expand them. Now to expand these two, I'm going to say here x multiplied by 5x squared. So I'm going to have a 5x cubed. And if I say x multiplied by -30, that will give me a -30x squared. Now if we say x multiplied by a 2 here, we're indeed going to have here a plus 2x. Now we then multiply the 3 with the negative 5x squared, and that will give us a negative 15x squared, and we multiply the 3 to the negative 30. That should be 90, because 3 times 9, 3 times 3 is a 9, so I'm going to have a 90x there, and it's positive because a negative and a negative will give me a positive. Now a negative 3 times a negative 2, that will be a negative 6 there. Now I'm going to take this 6 to come to this side, so that now I'm going to have a negative 6 is equals to a 0. From here we can group the like terms. So if you look at the x cubed, we only have 1. I'm going to keep it as it is here, 5x cubed. And if you look at our x squared, I'm having a negative 30x squared, negative 15x squared. So I see a 45 here, because the 5 and the 0 is a 5, and then 3 and a 1 is a 4. So I see a negative 45x squared. And if we look at the x here, I'm having 2x plus 90x. That should be simply 92x. And the 6 minus 6 should give me a negative 12, which then will be equals to a 0. Now we then have a cubic polynomial equation to deal with here. There are a couple of ways in which one can do this. For example, you can use long division method, you can use synthetic method, or you can use factorization by inspection. I personally would prefer to use factorization by inspection. I find that very easy for me. You can use any method that you are comfortable with to factorize this. I have to mention that I really hate long division. But anyway, so with inspection method, we know that this will have two products. We will have a binomial multiplied by a trinomial. So here we'll have a standard form of a parabola, ax squared plus bx plus c. And this side here will have a factor, which will be given by x minus something or x plus something. We'll try to figure that out as to which number it will be. Now, to find that factor, what we normally do is that we test different values of x. I'm going to use different values of x. So I'm going to test plus or minus 1, plus or minus 2, plus or minus 3, and so on. I'll continue doing that. I'll test all those different numbers. So what I mean when I say test, I'll put a 1 here and see what I get. I'll put a negative 1 here and see what I get. Now, and I'll do that. I'll put 2, I'll put negative 2. I'll test all those numbers. Now, the one that will give me a 0, in other words, if I get a 0 here after putting that number, it will then mean it is equal to 0. The two sides are equal. So that means that number is actually a solution. It is a root to this equation. It's a solution or a root to this equation. It's the one that will become a factor. We call it a factor, that number. Now, it's easy to find a factor in this specific equation. Why? Because of our values of x, we actually know them. My values of x should actually be the value of x here at d, because this equation is found by taking d and f. And also the other one should be the value of x here on e, and the other one should be here on c. Now, I can't use d and e because I don't know them. I'm trying to find those coordinates. But I can use actually a 6 because I know that this point here is a 6. So 6 will definitely be my factor. But to confirm that, I'll actually pull my calculator. Here we'll have a 5. And we put a 6 here because, I'm saying a factor is a 6. Then we're going to have a negative 45. And then we're going to have a 6. It's a squared. Then we have plus 92. And a 6. Then we have negative 12. Do you see that this gives me a 0? So it means 6 is a factor. So this means here my binomial or my factor will be written as x minus 6. Now I'm writing this as x minus 6 because remember, if we put x minus 6 is equal to 0, we'll then get x is equal to 6. So the value of x is a 6, but when I take it back here, it becomes negative. As a factor, it will come out as a negative. Now, having done that, you will notice that for me to find the term here, the first term here in a trinomial, I have to multiply x and this number here. So that means this number here will be a 5x squared, because if I say x times 5x squared, I actually get 5x cubed. Now, the other thing that will happen is that here we'll normally have a variable bx. Remember, I said I'm trying to reconstruct a parabola here. So this part of it, so this one we can figure it out. This part of it is difficult to figure out, so we'll just leave it as bx. It's not so obvious to see. And if I'm saying I have a 6 here, it means if I multiply a 6 and a number that should be here, I should get a negative 12. And for me to get a negative 12, it means I have to put a 2 here. Because if you say negative 6 times a 2, you get a negative 12. Now the question would be, how do we then determine the middle part here, the number there in the middle? Well, it's easy to do that. You would realize that if we multiply the 6 and 5 there, we actually get a negative 30x squared. And if we then multiply the x and the bx there, we then get a bx squared. Now these two, if I combine these two, if I add these two, they actually should give me a negative 45x squared. They should be equal to negative 45x squared. Now, why do I say that these two numbers will give me this number here? Is because if you look at carefully on these numbers, they are the square numbers. They have the x squared in them, so they will reproduce x squared. There's no way they can reproduce this, that, or even that. Now, from here, then we can find the value of b. I will basically just take this to this side so that I have bx squared is equals to. So here I'll have a minus 45 plus a 30. Because this 30 here will be a positive 30. So when we say minus 45 plus a 30, that should give you a negative 15x squared. And you can see that b will therefore be equal to what? A negative 15, because, you know, the x and the x squared and the x squared would cancel each other. So this means here we have a 15. Now this equation will then transform to be factorized in a sense that now we have x minus 6, 5x squared minus 15x plus a 2 is equals to a 0. And at this stage, we would then say either x minus 6 is equals to 0 or 5x squared minus 15x plus 2 is equals to 0. Now, this one, I can't readily see factors here. I'll just use the quadratic formula. I'll focus on this side to say it means this side we're going to have x is equals to a minus 15. So we're having a 15 here, plus or minus the square root of negative 15 squared minus 4. A is a 5 and C is a 2, all over 2 times A, which is a 5. Then we're going to punch a calculator to then find these values of x. So this means here I'll say therefore our values of x will be equal to a 6. So it is this one here. It will be a 6. Or x, it will be equal to something. Or it will be equal to something as well here. Now we're going to punch this on a calculator to find those other ones. Now to get this on our calculator, we will then say we have 15 here plus root of 15 squared minus 4 times 5 times 2 all over 2 times 5. And this gives me one of the values to actually be 2.86. And if I put a negative here, I then get 0.134 if we round that to two decimal places. So these are my values of x. Now, normally, I advise that when you work with graphs, you can analyze them. If we look at these two numbers, do they make sense? Can we see this on a graph? So if you look at 2.86, so the number here, we are saying that here we have a number of 2.86. So this is the number of x here. And it makes sense because we have a 2 here and a 3. We are almost close to a 3. So that makes sense. I have a lot of confidence in that. Then the other one is 0.14. So D here, you can see that it's going to be something like 0.14. This makes sense here because it's before 1 and a 2 as well there. So my answers make sense. That means I can continue to then find the corresponding y values, because remember, I'm looking for the points. I need to also find the y value here. I need to find the y value here on E, right? Just below the just above the turning point. Now to find the corresponding y values, it means I'm going to take these numbers and substitute them on either the equation of the parabola or the equation of the hyperbola. So I'll go and take the 2.86 and put it here, or put it on the hyperbola, which we said is defined by this. Whatever becomes easy for you. So if I use the parabola, I will then have 2.86 squared minus 30 times 2.86 plus a 40. Then I get a point of negative 4. Remember, negative 4.9. Remember that the 2.8 we said is a point here. So it will give us a negative. And check this number. This number here is a negative 4.9. It is just above the 5, which is a turning point. So, I'm smiling if I'm in an exam and I'm getting such numbers. So it means this point here, I'll take it to be point E. I'll say my point E will be given by 2.86 and negative 4. What did we get there? 90. So 90. So that is the coordinate that I'll have. And we're going to do the same with the point D, which is 1.4. So this means on my equation, I'm going to put now here the 0.14, the 0.14, so that now I have 35. So I'm going to have a 35 point, so here we're going to have a 90 because the 9 there will throw a 1. Now let us look at this point here. We are saying that if we put this number here, we should get a 35. So here we are mapping a 90, negative 90, and we're saying here we're getting a 35.90 as well. Now 35.90. This will make sense to me because if I have a 35 here and I'm having a 38 here, they're not far apart from each other. That's really comforting. It really makes sense to me. So that is how you will find your coordinates of D and E. And this is quite a lengthy problem. It is worth 6 marks. So you would see that your 6 marks will really come from putting this statement together, being able to see that the y values are the same. The two functions are actually intercepting each other. And you will get a mark for writing the cubic form. And there will be a mark for you being able to factorize this. So already we have 3 marks there. And you will get a mark for finding each point. And another mark will be reserved for doing simplification. All these simplifications that you have done there, they will give you 1 mark. And all those points will give you a total of 6 marks.